Hello, my fellow mathematician. Welcome to linear algebra. Welcome to linear algebra, whereby this is a matrix of 2 by 2, and you are required to solve the value of x here. On the second matrix also, it is a matrix of 2 by 2, and you are required to solve the value of y. Now, the condition is that you are doing these two matrices, both number 1 and number 2, they are a singular. They are a singular matrix. So, when a matrix is singular, determinant of a matrix singular is equal to 0. So, we are going to begin with this one for number Roman 1. So, we get the determinant, which is found by the product of the main diagonal. You subtract the product of the other diagonal. That is how we obtain the determinant. Then we equate it to 0. So, we are going to have x into bracket x plus 8 minus 6 times 8, which is 48. This will give you 0. So you remove the bracket. We begin here by removing the bracket. So you have x squared plus 8x minus 48, which is equal to 0. So here you have 48 and 8. You ask yourself, what are the two numbers which, when you multiply, will give you 48, and when you add them, will give you 8. Our numbers are 4 and 12. So you have x squared plus 12x minus 4x minus 48, which is equal to 0. So here I have substituted 8 with 12 and negative 4, because 12 minus 4 is 8, and 12 times 4 is negative 48. 12 times negative 4, sorry. So we factorize by pairing. We pair the first two and the last two. So x is common in the first two. So factoring x, we will get x plus 12. In the last one, we factor 4 to get x, negative 48. When we factor negative 4 outside, it will give us a positive 12, which is equal to 0. Next, we factorize x plus 12, which is common. And here we will be left with x minus 4, which is equal to 0. So this tells you that x plus 12 is equal to 0, or x minus 4 is equal to 0. So x is equal to negative 12, or x is equal to 4. So we have solved for the value of x in that case. And clearly here you can see, when you substitute here, you will have x by negative 12 minus 12 will give you 0, which is equal to 0, meaning that our working is correct. Or x 4 minus 4 will give you 0. 0 times this number is 0. So our determinant is equal to 0. The matrix is singular. This matrix here is singular when x is equal to 4, or x is equal to negative 12. Because when you have here 4, this will be 12. 12 times 4 will be 48. 48 minus 48 will be 0. Or when x is negative 12. When x is negative 12, when x is equal to negative 12, here we are going to, negative 4. Negative 4 multiplied by negative 12 will give you 48. 48 minus 48 will give you 0. So either way, it gives you, the matrix becomes singular. The next one is this one here. So we are to obtain the value of y here, given that this matrix is singular. So what we do, we multiply the element of the main diagonal and we subtract the element of the other diagonal. So here we are going to have y into bracket y minus 1, then minus 3y into bracket y plus 1. This will give you 0 because the element is, the matrix is singular. So you have y squared, removing the bracket, minus y, minus 3y squared, minus 3y is equal to 0. So we collect the like term together. Here we have y squared and minus 3y, which will give you minus 2y squared. Minus y and minus 3y will give you minus 4y, which is equal to 0. Here we can factor negative 2, the 2, sorry. So I'll be left with the 2. So we can factor y here, y into bracket y plus 2 is equal to 0. So either y is equal to 0 or y is equal to negative 2. We can check and see when y is 0, this part here will give you 0, and when y is 0, this other part will give you 0, meaning that y is equal to 0 is a solution for this matrix to be singular. When y is negative 2, here we are going to get, you have negative 3 multiplied by negative 2, it will give you 6. Here you have negative 6 multiplied by 1. So you have 6 minus 6, which will give you 0. So those are the values of y. And generally, when your matrix is singular, you equate the determinant to 0 to get your result.